I made a video tutorial about metric conversion using ratios, and if you introduce some shortcuts into those ratio problems, we can get dimensional analysis. So what this is going to do is show you how to work a problem just starting from my shortcut of dimensional analysis. So let's say the problem says convert 99.5 megahertz to hertz. The first thing you have to identify is what is it they're asking you to find, because that is whatever x is. So they gave me this number. This is what I don't know. My answer is going to be in hertz. So I need to know x hertz is equal to 99.5 megahertz. Once I've established that that's what they're asking me, how many hertz is equal to 99.5 megahertz, then I just assume that this is one giant numerator and it's all over 1. Every number is over 1 pretty much. So then I look at my metric conversion chart, and this is a capital M, which means it's mega. If it was a lowercase m, it would be milli, but the capital means mega. Then we look and it says 1 mega thing is equal to 1 times 10 to the 6th things. I'm going to replace thing with hertz. It's not on this list, but I can do it. 1 capital M hertz is equal to 1 times 10 to the 6th hertz. That's the equivalence statement, but that won't do me any good in this problem. I need a ratio in a fraction format. So I'm going to write the two possibilities that I could use. In the first possibility, I could have 1 megahertz in the numerator and 1 times 10 to the 6th plain hertz in the denominator. The reciprocal is also a completely legitimate ratio. We could put 1 times 10 to the 6th regular hertz per 1 megahertz. We now have these two ratios that we can choose from to decide which one will correctly solve our problem. If I put this one in, I have a megahertz on top, a hertz on top, and a megahertz on bottom. That would enable me to cancel these and be left with just hertz. That's the one I'm going to want to use, but let me show you why the other one does not work. If we use this one instead, this is multiplying across here, and then we would divide by whatever's on the bottom. So I would multiply megahertz times megahertz and try to divide by hertz. They're not the same, so I can't use this one. I have to use this one. And because I have megahertz on the top and on the bottom, they have dropped out, as some of you guys say, and then now I just have to multiply these two numbers together. I need to multiply 99.5 times 1e6. The calculator did not put it in scientific notation for me, so I'm going to write it out. It's 995,000,000. The only units that were left were hertz. You could leave it this way, but we have scientific notation just so that we can take long numbers like this and write them a little bit shorter. To put it in scientific notation, I need to have a coefficient that is between 1 and 10. So I need to do 9.95. That would be greater than 1, less than 10. Then I need to say times 10, and however many times it took to get the decimal point from this invisible place at the end to that location in between the two nines is my exponent. That was 1, 2, 3, 4, 5, 6, 7 times. 9.95 times 10 to the 7th hertz is your final answer.